right, in this lesson, we are going to be talking about the factored form of a quadratic function. So we're just going to kind of do a little review over factoring so that we remember. If I have a trinomial with a 1 as the coefficient on my x squared, then I can immediately begin factoring. I have a plus at the back, so I look up front and have a plus, so I have 2 plus signs. And then to get x squared, I have x times x. And then I'm looking for two numbers that are going to multiply to make 12. Now, as I list the numbers that multiply to make 12, I'm going to be thinking, do those two numbers also add to make 7? So I start with 1 and 12. That adds to make 13. So I have 2 times 6. That adds to make 8. 3 times 4, that adds to make 7. So my two numbers are 3 and 4. Doesn't matter where I put the 3 and where I put the 4 because those sets were exactly the same in front of that. Now when I have a number in the front of my x squared, I'm going to have to do the illegal move. Now remember, you always check for a common factor. I'm just getting through these notes so I know that I don't have one. But if you do, you should always take that out first. So 2 times negative 3 is negative 6. And then I go ahead and factor as usual. I have a minus in the back, which means 1 positive, 1 negative. And then I have my x times my x. And I'm looking for two numbers that are going to multiply to make that 6, but subtract to make 5. So I have 1 times 6. That does subtract to make 5, but I need it to subtract to make negative 5. So I need the 6 to be negative and the 1 to be positive. So 6 will go with the negative and 1 will go with the positive. And then I have to undo that illegal move by dividing both of these by 2. If they reduce, you always reduce first. 1/2 does not reduce, so I'm going to pull that 2 that's in the bottom in front of the x and leave the 1 behind. And then 6 divided by 2 is 3. All right, on number 3, I don't have a common factor, but I do see that I have two perfect squares and a minus sign. Now remember, if you wanted to view this as being x squared with no x in the middle, you could factor it like a normal trinomial. But if you already know you have two perfect squares with a minus, then you know that you get one of each sign. The square root of x squared is x, and the square root of 9 is 3. All right, on number 4, again, no common factors, but I do have a number in front of my x squared. So I'm going to do the illegal move just so I can do my little tricks for factoring. So gives me 6 at the back. I have a plus at the back, which means I have 2 of what's up front. So that gives me x minus and x minus. And I'm looking for two things that multiply to make 6, but they both have to add to make 7. So 1 and 6 do add to make 7. It doesn't matter where I put the 1 and where I put the 6 because both of these were exactly the same in the front. And then I have to divide both of these by the number that I multiplied, which was the 3. So divide both by 3. 1 over 3 does not reduce, so I'm going to pull that 3 in front, which gives me 3x minus the 1 stays behind. And 6 divided by 3 is 2. All right, number 5. The graph shows the function defined by that equation. How do the zeros of the function relate to the factors of the expression? So as you can see, our zeros are the negative 4, 0 and the 2, 0. And they're asking us to compare that to the factors of that expression. So let's factor the x squared plus 2x minus 8. So since I have that minus at the back, I automatically have 1 positive and 1 negative. I have the x and the x, and I'm looking for two numbers that multiply to make 8. At the same time, they must subtract to make 2. So 1 times 8, that subtracts to make 7. 2 times 4, that subtracts to make 2. I need it to subtract to make positive 2. That means I need a positive 4 and a negative 2. So 4 will go with the plus, 2 will go with the negative. Well, I see here that I have a 4 and I have a 2, and I have 4 and 2 here. Now they're opposite signs, and there's a reason for that. So if you notice on both of these points for our zeros, remember zeros and x-intercepts are exactly the same thing. All right, so if I look at these zeros, I notice that both of them have a y value of 0. That's because these are the x-intercepts. The x-intercepts are the same thing as zeros. So if I were to say maybe replace this y with 0, that means this whole factored out equation here, that's the same thing as this, just in factored form, would equal a y value of 0. And then I could solve this. Now we have a property that is actually going to be on a different page called the zero product property that tells me that if I'm multiplying two things here, so for instance, let's say that I had 0 times 2, and I wanted that would be equal to 2. Well, anytime I take something times 0, I get 0. So if this were equal to 0, I would have x plus 4 times 0, which would be 0. And if the x plus 4 were also 0, then I would have 0 times x minus 2, which would be 0. So I just need to figure out what would make x plus 4 equal to 0. And I would need to figure out what would make x minus 2 equal to 0. Because if either one of these equals 0, the whole equation equals 0. Well, if I solve for x by subtracting 4, I know that when x is equal to negative 4, this will equal 0. Now that would have been easy to figure out because negative 4 plus positive 4 would be 0. All right, over here, again, you could probably just tell that x is going to be 2, but if I solve this algebraically and I add the 2, then x equals 2. So the negative 4 and the 2, those are the zeros. All right, and I know that they would be my intercepts here, and I get those from the factor of my expression. So if I took a look at number 6 here, it's the exact same thing except we have a different equation, and I didn't label these on here, but it looks like it's going to be negative 4 and, or not negative 4, positive 4 and 5. Well, let's see if that works out. So let's factor our equation, and I'm going to go ahead and set it equal to 0 because I know that any x-intercept or 0 has a y value of 0. So I'm just replacing this y with 0. I have a plus in the back, which means 2 of what's up front, so I have 2 minus signs, x and x. And I am looking for two numbers that multiply to make 20, and at the same time they have to add to make 9. So I have 1 times 20, but that adds to make 21. 2 times 10, but that adds to make 12. 4 times 5, that adds to make 9. So I have 4 and I have 5. So again, if I set each of these equal to 0 and I solve, I will know what those x-intercepts are. Even though I can see them graphically, I'll know algebraically. So I will add 4. So when x equals 4, my equation is equal to 0. I will add 5. So when x equals 5, my equation is equal to 0. And if you look, that is the point 4, 0. And this is the point 5, 0. Those are my zeros. All right, and here's that zero product property that states that if a product of real number factors is 0, then at least one of the factors must be 0. So in the case where you have two factors, if a times b equals 0, that means that a has to be 0 or b has to be 0 or both. So to use that zero product property, you will rewrite the equation so that it's an expression equal to 0. Then you will factor and solve. All right, so first things first, I need everything to be on one side of my equation. So I see that I have an x squared and an x over here. Now we like for x squared to be positive. So I would prefer to just move this 42 to the other side. So I'm going to subtract 42. Now I need to make sure that this is put in standard form. 42 can't be combined with the x or the x squared. So x squared should come first, and then x, and then the minus 42. And that would be equal to 42 minus 42, which is 0. So we need everything on one side, and then we're going to factor. Since I have a trinomial here, I have a minus in the back, so I would have 1 positive, 1 negative, my x and x, and I'm looking for two things that multiply to make 42. So I have 1 times 42, but that doesn't subtract to make 1. So I know I'm going to need two numbers right next to each other. So I'm just going to jump because I also know that 6 times 7 makes 42. And that would subtract to make 1. I need it to be a positive 1x. So that means my 7 needs to be positive and my 6 needs to be negative. Now I set both of those factors equal to 0. And I solve. So subtract 7. X equals negative 7. Add 6. So x equals 6. And those are my two answers. Also, just a fun fact, if the degree or the largest exponent here in this is 2, you would have two answers, or an answer sometimes that counts twice. Sometimes you can get the same number twice. All right, so I look at number 8, and I need everything on one side, and it's very tempting to want to subtract the 2x squared. However, I really don't want an x squared that's negative. So I'm going to go ahead and add the 9x. So that will be removed from the right side, and then I'm going to subtract the 5 as well. So I'm killing two birds with one stone here. I've got 2x squared, and then 9x can't be combined with that or anything else, so plus 9x. And then I have the minus 5. Remember, you need to be in order here. Your x squared, then your x, then your number without the x, your constant. All right, so I have a number in the front. Now I'm going to look and say, can I divide all of these by 2? The answer to that is no. So I'm going to have to do my illegal move. I'm going to take the 2 times the negative 5 at the back. That gives me x squared plus 9x minus 10 equals 0. And then I will factor just like normal. I have a minus back here, which means I automatically have 1 plus 1 minus. And then I have my x times my x to give me x squared. And I'm looking for two things that will multiply to make 10 and at the same time subtract to make the 9. Well, luckily, that's just 1 times 10. So I need a positive 9 in the middle. So 10 has to be positive, 1 has to be negative. And then I don't want to forget to undo that illegal move. So I'm going to divide both of these by 2. 10 divided by 2 is 5. 1 over 2 does not reduce, so I'm going to pull that 2 in front of the x. So I have 2x minus 1 equals 0, and then I set both of those equal to 0. Both factors. And I solve, so I get negative 5. And then over here, to solve for x, I would have to add 1. So that gives me 2x equals 1, and then divide by 2. So x is equal to 1/2. Now, I also want to mention, remember, when you solve these by making them equal to 0, you are finding your x-intercepts. All right, those are where your graph crosses the x-axis. They are known as your zeros, your roots, okay? So if I took and plugged in, let's say I plugged in number 7, all right, which was x squared plus x minus 42. Now this is after you get it all on one side. If I go and graph that, I can see physically 1, 2, 3, 4, 5, 6. I cross right there at 6, and I also cross at 1, 2, 3, 4, 5, 6, 7, negative 7. All right, another thing I could do to check my answers is I could go to my table by pressing second graph, and I could plug in negative 7, and I could plug in 6. And as you see, that gives you a y value of 0. All right, so I can visually see that my answers are correct, and I can also go to the table and see that my answers are also correct. So I have two ways of checking myself, okay? All right, let's do a couple more of those. So again, I want everything on one side. I want to keep my x squared positive, so I don't want to move it. So I will just subtract 20. Now, 20 is not a like term with x squared or 8x. So I've got x squared plus 8x, and then minus 20 equals 0. And then I'm going to factor that. So I have a positive and a negative, x and x. And I'm looking for two numbers that multiply to make 20 that at the same time will subtract to make 8. Well, I know it's not 1 and 20, but 2 and 10 multiply to make 20 and also subtract to make 8, but I need a positive 8. So 10 has to be positive and 2 has to be negative. Then I set those both equal to 0. All right, I subtract 10. So I get x is equal to negative 10. Add 2, x is equal to 2. So my two answers are negative 10 and 2. And remember, those represent your x-intercepts, also known as your roots, also known as your zeros. So if you want, you can go graph the x squared plus 8x minus 20, and you will visually see that you cross at negative 10 and 2. You can also utilize the table. Now on number 10, I want the x squared to stay positive, so I'm not going to subtract the 2x squared. Instead, I'm going to move the 3x by subtracting 3x. Now that does not combine with the 2x squared. They're not like terms, so I don't have to worry about putting those together. I'm also going to subtract 2, which is also not a like term with any of those. So I have 2x squared minus 3x minus 2. All right, so I'm going to look at this. I can't divide 2 out of everything, and I have no like terms to divide out. So I'm going to take the 2 times the 2 and do my illegal move. So that gives me a negative 4 at the back. I have a minus back there, so 1 positive, 1 negative. I've got x and x. And I'm looking for two numbers that multiply to make 4. So 1 and 4, does that subtract to make 3? Yes, it does, and I need it to be a negative 3. So 4 has to be negative and 1 has to be positive. Now I multiplied and moved this 2, so I will divide both of these by 2. 1 over 2 does not reduce, so I'm going to pull that 2 to the front. 4 over 2 is 2, so I'll reduce that or simplify it. And I'm still equal to 0, I just haven't been writing my equal 0. So set both of these equal to 0 and solve. So I subtract 1 and divide by 2. So one of my zeros is negative 1/2. The other I just have to add 2, so my other is 2. All right, a multi-level driving range has 3 levels. Marco hits golf balls from the second level, which is 32 feet high. The height of a ball at x seconds, pay attention to that unit of measure, x is your seconds, after Marco hits it is modeled by the function h of x. When does the ball hit the ground? So they gave you a function, and they want to know when it hits the ground. Well, let's think about this. We have Marco. Let's just say this is the platform up here. He hits the ball, right? It's 32 feet up. So he hits the ball, and it's going to go, and then it's going to eventually hit the ground. Now remember, this x-axis is going to represent your ground here. And this is also your time, right? This is the time, and then this would represent your height. And we're trying to figure out how long it is before the ball hits the ground. Well, when the ball hits the ground, the height there would be a height of 0. So I want to know, when will the height, this represents the height, when will the height be 0? So I'm going to take that equation, negative 16x squared plus 16x plus 32, and I'm setting it equal to a height of 0. Now, in order to solve for the time, I have to factor. Well, I see that I have a negative 16, a 16, and a 32. All of those divide by negative 16. Now, I could choose to factor out a negative 16. That would give me x squared minus x minus 2. So if I go through and divide all of those by negative 16, this is what I get. Well, I still need to factor this, but I'm multiplying by negative 16, so I'm just going to divide that negative 16 from both sides. I can do that because I have an equation. All right, so now I just have x squared minus x minus 2 equals 0 divided by negative 16, which is 0. So instead of factoring that out, I could have divided everything by negative 16 to start off, since this is an equation. All right, now I'm going to factor. So I have a minus in the back. That's 1 positive, 1 negative, my x. And then I have 2. The only thing that multiplies to make 2 is 2 and 1. Does that subtract to make 1? Yes. But I need a negative 1, so 2 has to be negative and 1 has to be positive. Now I'm going to set those equal to 0. And I'm going to solve. So I get negative 1 and I get positive 2. Now, I have to think about this. This is a word problem, and a lot of times with word problems, if we get 2 answers, only one of them is valid. That's because we have to take into account that this ball is hit from here, but it would have went this direction if this was just a regular parabola. Well, I know that the x represents seconds. That's my time. Well, I can't have a negative amount of time. That would represent this 0. Whereas this represents this 0. So this is the only x that matters. And since we're in seconds, this would be 2 seconds. So it takes 2 seconds for the ball to hit the ground. All right, a baseball is thrown from the upper deck of a stadium 128 feet above the ground. The function h of x equals negative 16x squared plus 32x plus 128 gives the height of the ball x seconds after it's thrown. How long will it take the ball to reach the ground? This is another example where I need the height to be 0, because when the height is 0, I'm sitting on the ground. All right, so I'm going to take that negative 16x squared plus 32x plus 128, and I'm going to set that equal to a height of 0 and do the same thing. Now this time I see that all 3 of my numbers will divide by the negative 16 again. So I'm going to go ahead and, instead of factoring it out, this time I'm going to go through and divide every term I have on both sides by negative 16. So that gives me x squared minus 2x minus 8 equals 0. This is what I meant last time on number 11 when I was talking about, instead of factoring out and then dividing, you could just divide it out from the get-go. So now I'm going to factor what I have left. I have a minus at the back, so 1 positive, 1 negative, my x and my x. And I'm looking for 2 numbers that multiply to make 8 that will also subtract to make 2. Well, 1 and 8 subtracts to make 7. 2 and 4, that subtracts to make 2. So that would be the one I need. All right. So I have a negative in the middle, so I need my negative 2. So 4 will have to be negative, 2 will have to be positive. And then we're going to set those equal to 0 and solve. So I get negative 2 and positive 4. But remember, x is going to represent the time in seconds. Well, I can't have a negative amount of time, so the only answer that matters is the 4. So it takes 4 seconds for the baseball to hit the ground. Now I've added a couple more examples of solving for the variable. All right, notice on number 13, everything is already on one side. So I can immediately start factoring because I have no common factors. All right, I have a minus in the back, so 1 positive, 1 negative, my x and my x. And I'm looking for 2 numbers that are going to multiply to make the 14 that will subtract to make 5. Well, 1 and 14 subtracts to make 13. 2 and 7, that subtracts to make 5. So I need a negative 5, so 7 will be negative and 2 will be positive, and then we're going to set those 2 factors equal to 0. Then I will solve. So subtract the 2 and I get negative 2. Add the 7 and I get 7. So my 2 answers are negative 2 and positive 7. Now on number 14, I see that everything is not on one side. I do want to keep my x squared positive, so I'm going to go ahead and subtract the 3x. Now, I can't combine 3x with anything on this side on the left, but I do need to put this in order. So my 3x squared should be first, and then my negative 3x, and then my negative 60. Now, I do see that all of these will divide by 3, so I'm going to divide every term that I have on both sides by 3. That's going to leave me with x squared minus x minus 20 equals 0. And since I no longer have a number in front of my x squared other than 1, I can factor this. So a minus in the back is 1 of each sign, x and x. And I'm looking for two things that will multiply to make the 20 that have to subtract to make 1. That means that my two numbers are going to be right together. So 1 and 20 isn't going to work, and neither is 2 and 10. But I do have 4 times 5, and I need this to be negative 1. So 5 has to be negative, 4 has to be positive, and now I'm ready to set my factors equal to 0. So I subtract 4. So I get an x value of negative 4, and then an x value of positive 5. All right, so factored form can be written as y equals a number times x minus p times x minus q, where p and q are your zeros. So it's saying like if I had 2 times x minus 3 and x minus 2, then this would be p and this would be q. It's just like if I had it in factored form. The x-intercepts of the graph correspond to the zeros of the function, and the two zeros denote 3 different intervals of x values. So it kind of cuts it into pieces. So we are going to identify the intervals on which the function is positive and or negative. All right, so I failed to put the little y equals in front of this, so we'll pretend I had it there. So we have y equals x squared minus 2x minus 3. Well, I need to factor this, and I'm going to set it equal to 0 because I'm going to be finding my zeros. So we will factor this and set it equal to 0. I have a minus in the back, so 1 positive and 1 negative, x and x, and I'm looking for two numbers that multiply to make 3. Well, that would be 3 and 1, and that also subtracts to make 2. But I need a negative 2, so 3 has to be negative, and 1 has to be positive. Then I set these equal to 0. So again, I'm finding those x-intercepts, those zeros, those roots. So I'm going to solve, and that gives me negative 1 and positive 3. All right? So this is going to cut this into 3 intervals. All right? The first interval is going to be all of the x's that are less than negative 1, so all the ones to the left. The second interval is going to be all the x's that are between your negative 1 and your 3. And then the third interval is going to be all the x's that are greater than your 3. So I kind of want you to see this visually. So we're going to go to our y equals, and we're going to plug in that x squared minus 2x minus 3. Now, if I go to my graph, I see that my answers were correct. It was at negative 1 and at positive 3. So this has cut this into 3 little sections, okay? So this is the first section right here. If I drew a vertical line right down through this, I would have the left side, which is the x is less than the negative 1. And then I have a section that goes from the negative 1 all the way to the 3, and that's down here, this little u below the x-axis. And then I pick back up at 3, and now I'm back above. Okay, we have done this before where we identified where the graph was positive and where it was negative. That means where is it above the x-axis and where is it below. It's just now we are going to use this equation to help us. So we have the 3 sections, all right? Well, let's decide if it's going to be positive or negative in what section. So I'm going to start with the x is less than negative 1. That's to the left of the negative 1. Now, if I'm looking at this visually, if I look to the left, I can see that this is above the x-axis, so it's positive there. Same thing on this side. When it's bigger than 3, it's above the x-axis, and when it's between negative 1 and 3, we are below. So I have 3 sections. I'm going to start with the x is less than negative 1 section. So I'm going to choose an x value that's less than negative 1. Let's go with negative 2. So I'm going to take that negative 2 and plug it into my original equation. So I have negative 2 squared minus 2 times negative 2 minus 3. Now you can either plug that into your calculator or do it by hand, whatever you want to do, that's fine. If you want to put this into your y equals and use the table, that's fine as well. So we have negative 2 squared minus 2 times negative 2 minus 3 gives us 5. So my y value when x is negative 2 is 5. That's a positive number. So I know that I am above the x-axis when the x values are less than negative 1. So now I need an x value that is between negative 1 and 3. Let's just go with 2. So 2 squared minus 2 times 2 minus 3. That's going to give me negative 3. That's a negative number. So I know that when my x values are between negative 1 and 3, I'm going to be below the x-axis. All right, now let's do the right section. X is greater than 3, so let's just do 4. 4 squared minus 2 times 4 minus 3. That's going to give me a positive 5. So I know that when the x values are greater than 3, I'm going to be above the y-axis. So I have 2 sections where I'm positive and 1 section where I am negative. We saw that visually when we graphed this. So for the positive, I am positive when x is less than 1 and when x is greater than 3. Now, if I want to write that in interval notation, that would be from negative infinity all the way to negative 1 and from 3 to positive infinity. Those are on the outside edges. All right. I am negative in one spot, and that is when my x is between negative 1 and 3. If I want to write that in interval notation, that would be from negative 1 to 3. All right, so let's check out number 16. Again, we're going to factor to figure out where our zeros are. We have a positive and a negative, an x, and 2 numbers that multiply to make the 21 that will subtract to make 4 is 7 and 3, and I need a negative 4, so 7 will be negative and 3 will be positive. I'm going to set those factors equal to 0 and solve. So I end up with negative 3 and positive 7. So I'm going to set up my 3 sections. Negative 3, so that'd be x is less than negative 3. 7 is to the right of that, so that would be x is greater than 7. And then you have your middle, where x is between negative 3 and 7. So I'm going to choose an x value that's less than negative 3. So let's just go with negative 4. So we have negative 4 squared minus 4 times negative 4 minus 21 is going to give me 11. That's a positive number. So my y value is positive for all the x's that are less than negative 3. So I will be above the x-axis for x's that are less than negative 3. Then let's pick a number that's between negative 3 and 7. It can be any number between the 2 numbers. All right, just don't include negative 3 and 7 because those are your zeros. Let's go with 2. So we have 2 squared minus 4 times 2 minus 21. That gives me negative 25. That's a negative number. So my y value is negative when I have x's that are between negative 3 and 7. All right, and then we're going to pick a number bigger than 7. Let's just go with 8. So we have 8 squared minus 4 times 8 minus 21. That gives me 11 again. That's positive, so I know I have positive y values when my x's are bigger than 7. So positive, we have two sections when our equation is positive. One is when your x's are less than -3, and when your x's are greater than 7. Again, you could say -infinity to -3 and 7 to infinity. And then for the negative, that is the part in the middle. So when our x is between -3 and 7, you could write that in interval notation by saying -3 to 7. All right, let's do a couple more of those. So we have x squared plus 2x minus 8. I'm going to factor that. Again, there's a minus at the back. So one positive, one negative. And what multiplies to make 8 that will also subtract to make 2 is 4 and 2, but we need a positive 2, so 4 has to be positive, 2 has to be negative, and we're setting this equal to a y value of 0, and we are going to set our factors equal to 0, and we'll solve. So subtract 4, add 2, so I get x is -4, and x is 2. So I'm going to make my three sections. I have when x is less than -4, when x is between -4 and 2, and when x is greater than 2. So choose x values that are in those sections. I need an x value less than -4. Let's just go with -5. -5 squared plus 2 times -5 minus 8 is going to give you 7. So our y values are positive for x values that are less than -4. A number between -4 and 2, I'm just going to go with 1. So 1 squared plus 2 times 1 minus 8, that gives me -5. So I have y values that are negative when my x values are between -4 and 2. And then I need a number bigger than 2, so let's just go with 3. 3 squared plus 2 times 3 minus 8 gives me 7. So again, positive y values when x is greater than 2. So positives is when x is less than -4, which would be -infinity all the way to -4. And when x is greater than 2, so 2 and bigger. And then one section where it's negative, which would be when your x's are between -4 and 2. So that would be -4 to 2. All right, and last one of these. I see that I have a negative out front, so I can't immediately start factoring. I'm going to first set it equal to 0. And since I have an equation now, I can divide everything by that -1. That gives me a positive x squared, a -4x, a -12, and 0. Now I can factor positive and negative. What multiplies to make 12 that will subtract to make 4 is 2 and 6. And we need a -4, so 6 is negative and 2 is positive. And then I'm going to set those factors equal to 0 and solve. So I get -2 and positive 6. So I have x is less than -2, x is between -2 and 6, and x is greater than 6. So I will choose a number that is less than -2. So let's go with -3. So I have a -3 squared plus 4 times -3 plus 12. That gives me -9. So I am negative y values when my x is less than -2. A number between -2 and 6, let's just go with 3. So we have a negative and then 3 squared plus 4 times 3 plus 12. That gives me 15. So I am positive when my x's are between negative 2 and 6. And then a number bigger than 6, let's just go with 7. So we have negative and then 7 squared plus 4 times 7 plus 12. That gives me negative 9. So I am negative when my x values are greater than 6. So I am positive only in one section when x is between negative 2 and 6, or I could just write that as well. And then I am negative from negative infinity to negative 2, and from 6 to positive infinity, or I could just write those two sections. All right, number 19. Write the equation of a parabola with x-intercepts at negative 2, 0, and negative 1, 0, and which passes through the point negative 3, 20. Well, let's remember that we can write this as y equals a times x minus p times x minus q. And remember that p and q, though, that represents your x-intercepts. Well, they gave those to you. They gave you the negative 2, 0 and the negative 1, 0. Those are your x-intercepts. It does not matter which one is p and which one is q, as long as you have a p and a q. So I could have made the negative 2q if I wanted to. I could have made the negative 1p. It doesn't matter. The reason that we need this extra point that it goes through is because we don't know what the a is. So we are going to use this as our x and our y just to figure out what the a is. So I'm going to plug in for y the 20. I'm solving for a, and then x is listed twice. So we have to plug in the negative 3 for x here, but then we're also going to have to plug in the negative 3 for this x as well. And then we've got p and q. Well, I said that negative 2 was going to be my p, so I put negative 2 in here. Now, because of that double negative, that makes this a positive. And then I know that my q is going to be negative 1, so I plug in negative 1. Again, another double negative, so that makes this positive. And I am going to figure out what negative 3 plus 2 times negative 3 plus 1 is. You can just plug that whole thing in your calculator at the same time. You get 2. So this would be 2 times a, and then I'm going to solve for a by dividing by 2. So I know that a is 10. Now I can write my equation. Now remember, when you write the equation, y is going to be y and x is going to be x. So in for the a, we have 10, and then x minus p, which was negative 2, so that makes this positive 2. And then x minus q, which is negative 1, so that makes this positive 1. Essentially, it's going to be exactly this that you have here, except with the x instead of the negative 3. And there's your equation. So we can do the same thing here. My intercepts are 3 and negative 3, so I have a p and I have a q. The point that the parabola goes through is going to be my x and my y. So I have y equals 2 equals a, which is what I'm trying to find, times x minus p, which is 3, and then x again, which is 1, minus negative 3, that's my q, that's a double negative. So 1 minus 3 times 1 plus 3 ends up being negative 8. So I have negative 8 times a, divide by negative 8, reduce that, and a is negative 1/4. So I have y equals negative 1/4 times x minus p is 3 times x minus q, which is negative 3, so that's a negative 3, which will be positive, and then I have my equation.